This is a very, very famous experiment, and it's used as a classic example of showing how science will change its mind and develop new, better models to explain the world if new evidence comes along that undermines a previous model of how things were working. And this experiment allowed us to discover the nucleus of the atom. Right, to give you some context, first of all, we used to believe that an atom was based like something known as a plum pudding. Let me explain why. In 1897, the electron was discovered, and the scientist who discovered this, a chap called Thomson, realised, well, these electrons must come from somewhere, so he assumed they came from the atom, and that the atom must be must have a positive bit to it, because the electrons were known to be negative, so it was felt that maybe the atom had a big positive cake, shall we say. In it were sat these electrons which had a negative charge, and that's what you end up with. We knew the electrons were very, very small, and that's what people believed an atom looked like. If you went to school back in 1902, they'd say this is exactly what an atom looks like. And what you need to know about it, it sort of resembles a bit like a hot cross bun. If you imagine a hot cross bun these days, you've got bits of fruit in it. Well, in those days, they used to eat loads of plum pudding, and that's why it was called the plum pudding model. Now, a chap called Rutherford asked two of his students, chaps called Marsden and Geiger, to do an experiment to investigate what happened to alpha particles, and it's known as the alpha scattering experiment. This is what it looks like. They got a alpha source, basically a radioactive source giving out alpha particles, and an alpha particle is made up of 2 protons and 2 neutrons that travel very, very quickly. They've got a lot of energy, and this alpha source was put inside a lead box with a little hole in it, and this little hole has the effect of sending out a beam of alpha particles. The alpha particles go in all directions inside of the box, but get stuck by the lead, but through where the little hole is, they'll obviously come out as a beam. And when the alpha particles came out as a beam, they went through a vacuum. They couldn't let this happen in air because the air would stop the alpha particles. So they made it happen in a vacuum. They fired it out of gold leaf, and they expected the alpha particle to go straight through, and they could be detected at the far end by when the alpha particles hit a piece of metal, a very thin piece of metal at the end with a special chemical on it, they would flash. And by looking at a microscope at this screen, you could count the number of alpha particles coming through. And the scientists, these students, actually just measured the number of flashes taking place in a certain amount of time, and they would move the detector or microscope around 360 degrees around the whole experiment. Now, they were expecting the alpha particles to go straight through because it was thought that the plum pudding model meant that alpha particles, which were seen as much more powerful, much more destructive, would be able to go through the gold leaf very, very easily. So they expected most of them to go through, and sure enough, that's what happened. 99% of them did go straight through. But what surprised them, and indeed shocked them, was the fact that some of these alpha particles were being deflected by massive angles. So, for example, you could see a pile of blue lines going straight down, almost at 90 degrees. And if you look at the green one shows an alpha particle hitting the gold leaf, then bouncing straight back. And this caused an incredible shock. In fact, I remember chap Rutherford actually said it was as if someone had fired an 18-inch shell at a piece of paper and the shell had bounced back. People were not expecting that to happen. So they realised at that point then that their understanding of what an atom was like was wrong. And this is what they observed. They noticed that 99% of them go straight through. So this suggests that the atom is mostly space. The fact that 1 in 10,000 bounce straight back means that there must be, even though most of it is empty space, every so often they must hit something. And that thing must be very, very small for them to only hit it every so often. But it must be very, very dense because it's causing these alpha particles to bounce back straight back. So it must have been very dense and massive. By massive I mean it's got a lot of matter in it in a very small space. And they call this thing a little nut or nucleus. At the same time, because alpha particles are positive and the alpha particle were bouncing back, they realised that the nucleus must be positive. So they'd suddenly discovered the positive bit that they knew must exist somewhere. So they discovered the nucleus as well, and they knew it was positive. Now, and very often in exams, they'll show you a diagram like this. Now, this is supposed to represent, the red blobs are supposed to represent the nuclei of the gold sheet. Okay, so that they're far apart, lots of empty space. And on the left-hand side, you can see loads of alpha particles coming in. Most of them just go straight through. You know, 99% just go straight through because they don't get anywhere near any gold nucleus. But those that get close to it can be deflected by different angles. And if you get the occasional alpha particle go straight towards the middle of a nucleus, then it will actually bounce straight back. And that's what we're seeing here. This is explaining why the alpha particles are affected by the nuclei, because the nuclei are very strongly positive, and also they're very, very small, and so that's why most of them can get through no problem at all, but every so often one just bounces back at a strange angle. Very often the question will ask, what's the difference between a nuclear model, Rutherford's nuclear model, and the plum pudding model? Well, you need to say the nuclear model has got a nucleus, it is mostly empty space, and the electrons orbit the nucleus. The plum pudding has no nucleus. The positive matter is spread out, and electrons, instead of orbiting the nucleus, they sort of sit in this positive pudding. So those are the differences between the nuclear model and the plum pudding model. Of course, the plum pudding model is now wrong, it's clearly wrong, and now we go for the nuclear model until a new model comes along. And there you go, that is the very famous Rutherford scattering experiment and plum pudding model.